Okay, so this video is going to be about factoring. So we are going to run through the general steps on how to factor something and then pair that with a few examples. So if you remember a handout that I passed in class, which I'll attach to today's notes, the first thing you should always do is try to find a GCF, which is a greatest common factor. If, after you find your greatest common factor, chances are you're going to be in one of three categories. You're either going to have 2 terms left, 3 terms left, or 4 terms left. And based on the amount of terms will dictate what you're going to do. If there are 3 terms, you're going to look for a special case quadratic, like a perfect square trinomial. If it's not a perfect square trinomial, it's just a quadratic trinomial in general, you'll go through your normal factoring steps where you do the AC method and then you create 4 terms and you factor by what's called grouping. Let's do that in a different color. What multiplies to give you A times C and adds to give you B, and then you rewrite your expression in 4 terms so that you can factor by grouping. And I'll do an example of all these on a different slide. Now, if you have 2 terms, you're going to look to see if it is a difference of 2 squares, or if it's a sum of cubes, or a difference of cubes. Now, if after all of this, if it's 2 terms and it's not a difference of squares or a difference of cubes, and you can't just simply and it asks you to factor, you can't factor if it's not one of those 3 things. Now, if it asks you to solve, you could, isolate the variable or look at your graph and see where it crosses. Things of that nature are typical solving skills. 3 terms, if you can't get it to factor, you can just leave it alone. But all of these things we're going to be using to create factors, things that multiply together to give you something. And once we get those factors, we set those factors equal to 0 so we can solve an algebraic expression. So let's kind of run through what all of these will look like. Let's say I have the term 15x to the 4th minus 20x cubed plus 35x squared. So my first step is always pull out a greatest common factor. Well, these all can be divided by 5, and they all have at least 2 x's. So we're going to factor out a 5x squared. That will leave me with 3x squared minus 4x plus 7. And so now we're left with a factor that has 3 terms. So let's see if we can apply our see if it's a perfect square trinomial, and if it's not, let's see if we can factor it like a normal quadratic. So it's not a perfect square trinomial because that's not a perfect square and that's not a perfect square. So what we need to ask ourselves is there anything that we know that multiplies to give us 21, because that's A times C, and adds to give us negative 4? Well, I can't think of one. And so because there's nothing that multiplies to give me 21 and adds to give me negative 4, I know that I'm done. Now, if there was one small change, like say this were negative or the 7 were negative, what multiplies to give me negative 21 and adds to give me negative 4, then I could use 7 and 3. But in this case here, it can't work. So let's say we would just be done. That would be the factored form. But let's go ahead and say that this were negative 35x squared up here, and that gave me negative 7. So now what multiplies to give me negative 21 and adds to give me negative 4? Then I can see that it's negative 7 and 3. So I would rewrite this expression. like so, and I would factor by grouping. So what do these two things have in common? They both have an x, so that leaves me with 3x minus 7. These things have nothing in common, so we just put a 1, because 1's the only thing they have in common. That leaves me with a 3x minus 7. So now out of this big expression here, they both have a 3x minus 7 in common. So if we factor that out, that leaves me with x plus 1. And then, of course, don't forget your 5x squared that you factored out of the very beginning. So 5x to the 4th, or 15x to the 4th, minus 20x cubed, minus 35x would eventually factor down to 5x squared times 3x minus 7 times x plus 1. So if we wanted to solve, we could set each of those factors equal to 0 and solve for x. All right, let's look at a couple examples. I just kind of covered factoring out using the greatest common factor, factoring by grouping, factoring a normal quadratic. Let's look at some of those special cases. Let's say I would end up with an equation like this: x squared plus 10x plus 25. This is what's called a perfect square trinomial, and we know that because of this form here. I'm going to do that in blue. Perfect square trinomial. It's a trinomial because it has 3 terms. It's a perfect square because of this form. If you have a squared plus 2 times a times b plus b squared, it's a perfect square trinomial. And so look at that. What's the square root of x squared? Well, that's x. What's the square root of 25? Well, that's 5. And 2 times x times 5 equals 10x. So we know this is a perfect square trinomial. And when you have a perfect square trinomial, you know that it's going to be a plus b squared. Now if this 10x were negative, then it would be a minus b squared. So I don't have to factor this. I can jump straight to the fact that I know this is going to be x plus 5 squared. Now if you don't like remembering that rule, you could always just do your normal factoring steps. What multiplies to give me 25 and adds to give me 10, 5 and 5. You can go through your process and you would get x plus 5 squared. All right, what if we have, moving on to 2 terms? So that kind of covers the 3 and 4 term strategies of factoring. What if we have 2 terms? Well, let's say we have an x squared. Let's make it a little harder. Let's do 4x squared minus 36. We need to check if this is a difference of cubes, a difference of squares, or a sum of cubes. So we'll do difference of squares, difference of cubes, and sum of cube. Well, we know it can't be sum of cube because that's a minus sign. So is 36 a perfect cube? Is there any number that multiplies by itself 3 times to get 36? No, but it is a perfect square. The square root of 4x is 2x because 2x times 2x is 4x squared. The square root of 36 is 6. 6 times 6 gives you 36. When you have a difference of squares, so a squared minus b squared, it will always give you the factors a plus b, a minus b. So I know this is going to be 2x plus 6, 2x minus 6. And if you don't believe me, you can factor it out and check yourself. Let's do an example of a difference or sum, whatever, of cubes. Let's say I have x cubed. Again, let's make it a little harder. 8x cubed plus 27. Well, I know it's not going to be either of these because those are both differences. So is it a sum of cubes? Well, 8x cubed is 2x times 2x times 2x, and the cube root of 27 is 3. So yes, it is a sum of cubes. And when that happens, when you have a cubed plus b cubed, it will always equal a plus b, a squared plus, minus, it's always opposite, a times b plus b squared. So I know these factors are going to be 2x plus 3, 2x squared, which is 4x squared, minus 6x plus 9. And so you can see how you can kind of make these shortcuts. And in the next video where we start to solve, this will become important. I just want to go ahead and show one more example of the difference of cubes. Let's say I have just x cubed minus 1. Well, the cube root of x cubed is x times x times x. The cube root of 1 is 1 times 1 times 1. When you have a difference of cubes, that is a cubed minus b cubed, it will always become a minus b times a squared plus, because it's opposite, a times b plus b squared. So I know this factors over here of x cubed minus 1 is going to be x minus 1, and then x squared plus x, because 1 times x is x, plus 1, because 1 squared is 1. And those are the factors. So keep practicing this. Always be on the lookout for these special cases, because that can help you solve pretty complex problems. And you need to have these memorized so that you can add these to your toolbox to solve problems. That's it. Goodbye.